All right. All right, guys. Well, tonight we're going to work on the law of sines. So basically, why would you need a law of sines? Well, if you have a triangle that's not a right triangle and you try to find out like what the angles are and what the sides are, the way we've been doing trigonometry only works for right triangles. So we have now the law of sines, which will work for any triangle. So basically, the law of sines says that the sine of A over A, so the capital A's are angles and the small letters are side lengths. So the sine of A over A equals the sine of B over B equals the sine of C over C. I'm going to do like a really quick proof about it just so you can kind of see how it works instead of just like have it magically appear. But that is what the law of sines is. And just as a reminder, if you add up all the angles of a triangle, it always equals 180 degrees. So let's take a look at this. So if I want to show you how the law of sines comes into being, basically, hold on, let's use red. So basically, let's say I have this triangle here, and I want to find the sine of A. So notice that the original triangle is not a right triangle. But if I put that pink line down the center, and it doesn't have to be equilateral, even though this looks equilateral, it could be any triangle. So like for example, if I had a triangle that went like this, that's still a triangle, right? And if I wanted to make a right triangle, now this is a right triangle on both sides, right? So it doesn't have to be as pretty as that triangle. So if I wanted to find the sine of A using this triangle, the one up on top, what would the sine of A equal?
That would be the opposite over the hypotenuse.
Exactly. So for this one,
H over C.
H over C, exactly. And then if I wanted to find the sine of C, it's going to be H over A, right?
Mm-hmm.
Okay, so now, but they have the same heights for sure. So if I solve both of these for H, then I'll get H equals C sine of A. My thing is lagging. Hold on, let me see if I can close up something and have it go a little faster. Okay, let's see if that works. And then I can also say here that H equals A sine C, right?
Mm-hmm.
And since the H's are the same, I can set sine of A, C sine of A equal to A sine of C. I am definitely lagging here. Hold on a second. Let me see what else I can close. Maybe my computer's just about to die. Hold on. I think I lost it. Oh no, there's my mouse. Okay. Huh. Why did I lose my pen? Okay, I've definitely lost my pen. Hold on. I'm just trying to figure out how to fix this real quick.
Oh, you're good.
Yeah, definitely something's wrong here. So let me stop sharing. I think what I might have to do is reset my computer. Can you still hear me?
Yeah.
Okay, hold on. Let's see if stop sharing. Let me reshare and see if that fixes it. Let's see. Oh, good. Okay, that was way easier. So C sine of A is equal to A sine of C because both of these have the same H, right? So I could set the others equal to each other. And then, well, I can divide both of these fractions by AC. And the reason I'm doing that is because here I'm going to cancel my C's and here I'm going to cancel my A's. And notice what I end up with is the sine of A over A is equal to the sine of C over C. And if I, did two different angles, I would be able to show that I would be able to show you what the exact law of sines, which is sine A over A equals sine of B over B equals sine of C over C. So that's basically why. Okay.
Mhm.
Does that all make sense?
Yes.
Okay, good. So I want to solve a triangle, and when I draw a triangle, it doesn't really matter what it looks like. Okay, but there are certain things that do matter. For example, if I label this A, B, and C, and I can label A, B, and C anywhere I like, but if I label it like that, then the side A is always across from angle A, and side B is always got to be across from angle B, and side C has always got to be across from angle C. That is very important, or else it wouldn't work. Okay, so now they're giving me that this is 40 degrees, and this is 60 degrees, and this is equal to 4. So I can add up 40 and 60 and get 100. And since all my angles together have to add up to 180, I now know that this is 80 degrees. Okay.
Mhm.
Now, once I have all my angles, the law of sines is very straightforward. So here, I'm going to have to use A because I have sine of A over A, and that's the only one that I have both variables. So I'm going to start by saying that the sine of A over A is equal to, and then it doesn't really matter. Let's just say the sine of B over B. Okay. And so here we go. Sine of A, so sine of 40 degrees. And this is obviously a calculator problem because I don't know what the sine of 40 degrees is, and I don't expect anybody does, equals the sine of 60 degrees, which we do know, over B. So if I want to solve for B, I can say B is equal to 4 sine of 60 degrees over sine of 40 degrees. Basically, I'm almost cross multiplying, but really just multiplying both sides by 4 and then both sides by B, and then dividing both sides by sine of 40. So now I know what B equals. Let me get my calculator. And again, now we're in degrees. And the last time I used my calculator, we were in radians. So really always check. So I have, well, I know the sine of 60 degrees is I know what that is, right? That's the square root of 3 over 2.
Right.
Okay. So all I really need to know, what is the sine of 40 degrees, which is 0.643-ish. So so that's really 2 times the square root of 3 divided by 0.643. And I get that B is equal to approximately 5.39. Now, how do I know if this seems kind of correct? Well, I know that the side across from any angle is going to be really proportional to the angle in a way. So because A is the smallest angle, this side across from A should be the smallest side. So the next smallest angle is 60 degrees. So that's good that this is bigger than A. So I feel like I'm on the right track. If it was smaller, I could tell I made a mistake somewhere, right?
Mhm.
And then again, the same thing, I just really have to do again. So I can say the sine, because I have A, B, I just need C. So the sine of C, and C is 80 degrees over C is equal, and I'll just go back to A because it's nice and easy. So sine of A, which is 40 degrees over A, which is 4. So C is going to equal 4 times the sine of 80 degrees over the sine of 40 degrees. And again, I have to use my calculator because I don't know any of those. So I have 80 degrees. So the sine of 80 degrees times 4 divided by sine of that. And I get, for this one, I get 6.13. So that would give me 6.13. And again, I'm very happy to see that it's bigger than A and B because it should be. So I've actually solved this triangle. I know A, B, and C. So I know all my angles. And now I know all my sides. And that's really all there is to the very basic law of sines. So if you're given 2 angles, you always can get the third angle. And once you have all 3 angles, it's very simple to just do, I don't know why that happened. Okay. It's very simple to just solve for these other variables. Do you agree?
Yes.
Okay, good. Because I don't want to do a lot of these. I mean, I don't mind doing one more, but the harder ones are the ones where you're only given 1 angle, because then you don't have all 3 angles. But
Right.
again, here we have 2 angles. So I know my third angle is going to be 180 minus 50. So it's going to be 130 degrees, right? So again, I do the exact same thing. I'll just do another example just for the heck of it. So I'll call this A, I'll call this B, I'll call this C. That means this is C, this is A, and this is B. So this is obviously not to scale. This is 130 degrees. This is 35 degrees. And this is 15 degrees. And I know C equals 5. So again, I just do exactly the same thing. So I know everything about C. So I'm going to always start with the thing, the sign that I know the variables of. So I'm going to start with sine of C over C, and then it doesn't really matter what else I use. So I'll do A over A. So again, I get the sine of 130 degrees over 5 is equal to the sine of 35 degrees over A. Solving for A, I get 5 sine of 35 degrees divided by the sine of 130 degrees. And that gives me so does that make sense? So I get A equals 3.74 and C, yeah, A is smaller. Okay, so let's say it is true. Okay, and then again, so this is one set of values. And then I can do the same exact thing for B. So I have the sine of C. I'll just write it out. Over C equals the sine of B over B. So again, I have the sine of 130 degrees divided by 5 is equal to the sine of 15 degrees over B. And that means that B is going to equal 5 sine of 15 degrees divided by the sine of 130 degrees. And let's see, we get 15 sine. So I get for B 1.69. So this is 1.69. And again, do I know the numbers are correct? I don't know. I could have made a mistake, but I know that they make sense because the smallest side is across from the smallest angle and so on. So it's not an obvious error. Okay.
Mhm.
Okay, so now let's see. This is where things get a little different, and I'll explain the picture in a minute. But let's say I have a triangle. And again, this time I only know one angle, which is C, which is 28 degrees. Sorry. And then this is going to be C, B, and A. And I know side C equals 60. And I know side B, oh, they're giving me two sides. So I know side B equals 100. I don't know the other two angles, and I don't know A. So first I'm going to solve it, and then I'm going to explain what that picture is trying to show. So again, I can use, so I can say here, I'm going to obviously use my, let's see, what am I going to use? I'm going to use my C because I know both of my C's. So I can start here with the sine of C over C equals, and the other one I'm going to use is B because I don't know what the sine, I don't know what the angle B is, but I know the side B. Okay. So again, I have sine of 28 degrees over 60 is equal to the sine of B, which again, I don't know, over 100. So if I solve this, I get 100 sine of 28 degrees over 60 is equal to the sine of B. So I can find out that B is equal to the inverse sine of 100 sine 28 degrees divided by 60. So far that makes sense, right?
Yes.
Okay, good. Let me see what number I get. Actually, do they tell me? No. Okay, so let's see. We have 28 degrees sine 100 divided by 60. And yep, I'm still in degrees, so I want the inverse sine of that. And this equals, let's say 51.5. I'll just round it to one decimal place. So now I know that I have B equals 51.5. Okay. Now, here's the thing. Remember, if we have the sine of B equals some value, and I don't remember what this value was, but it is just a number, and we think about our unit circle, I know that in quadrant 1, this is 51.5 degrees, right?
Mhm.
And that would give me the right answer. but I get the same exact value because it's sine in quadrant 2, where this is 51.5 degrees, right? So I know that B is either equal to 51.5 degrees or 180 minus that. Because that would be the angle in quadrant 2. Does that make sense?
Yes.
Okay, perfect. So I have two possibilities. Let's see, what's 128.5, I think that is. So I have two possibilities, either 51.5 or 128.5. So now I'll explain the picture on the right. Notice here with this, there's my B is 100 feet. And here is angle C, which is 28 degrees. But I can either make the triangle like this, right? Or where C is 60 feet, or I can find another side that looks like this, because that is also C equals 60 feet. And that's all I'm given. I don't really know what these other angles are. Does that make sense?
Yes.
Okay, perfect. So if I have this triangle with this side, then this is my other side. If I have the bigger base, then that's my other side. So I'm going to have two possible triangles. So here's what I want to, I really recommend you do this because it really helps. So I make a table and I say, let's have these are all the angles and here's all the sides. And here's triangle 1 and here's triangle 2. Because I'm either going to this is called the ambiguous case. It's the ambiguous case because I only have one angle. So the other angle has multiple possibilities. So I can have this could make either 0 triangles, 1 triangle, or 2 triangles. And I will show you how to figure it out. So first, I always put in what's given. So what I'm given is, am I given A? Nope. I'm not given B, but I am given C is equal to 28 degrees, which means I can't change that. I'm also given that side B equals 100. Obviously, that can't change. And side C equals 60. And again, that can't change, right?
Mm-hmm.
But now for B, I have these two possibilities. So in B, I'll make triangle 1, 51.5, and triangle 2, 128.5. And now I add up 51.5 and 28 because that will tell, and I subtract that from 180, and that will tell me what angle A is. So I'm going to just use a calculator just because I'm a little lazy tonight. 51.5 plus 28. So I get 100.5 as the other angle there. And this is going to be 156.5. Track 180, I get 23.5. So those are my two possible triangles. And then the last thing I have to do is find A, and I have to find it twice because I have to find it for triangle 1, where, as you see, these angles are different than triangle 2. So I would have, that's the only thing missing. And how would I do that? I would just use sine A over A equals sine B over B, or C over C, whichever you like. And if you want, I'll complete it, but it really is exactly the same as I've done in the other two cases. The
Yeah.
hardest part is figuring out how many triangles we have and what their possibilities are. Excuse me.
You go ahead. I was gonna say you don't have to finish it.
Okay, because it really is just exactly like the first two cases.
Right.
So that had two triangles. How did I figure it out? Because there are two available triangles. We'll see as we go through that that's not always the case. So let's do this again. And let's see, let's just make this again. You don't have to make it in the same order as I'm making it. That does not matter. So this is 40 degrees. This is 200. And this is 220. And again, I'm going to start with my table because I have to make it anyway. So A, B, C, A, B, C, triangle 1, triangle 2. Okay, so what are we given? We're given that A is 40 degrees. I like to do this in a different color so that I don't. So A is 40 degrees. Has to be, that's what's given. Side A is 220 feet. Again, given. And side B is 200 feet. Again, given. So now let's draw our triangle. Oh, I already did draw my triangle, sorry. So now what we're going to do is we're going to look here and we're going to solve for which variable do you think we have to solve for?
We're gonna solve sine A over A equals sine B over 200.
Exactly, because that leaves me with just one unknown, right? If I tried C, I don't know what side C is and I don't know what angle C is. So I'll have two unknown variables. It won't work. So again, we have sine of A. Well, I'll write it. Sine of A over A equals sine of B over B, which means that I have sine of 40 degrees over 220 is equal to the sine of B, which again, I don't know, over 200. I solve for sine of B equals 200 sine of 40 degrees divided by 220. And then I take the inverse sine of both sides. And I end up here with B equals the inverse sine of 200 sine of 40 degrees divided by 220. And that equals, 1 second. So this equals, I'll just give you the in-between value also in case anybody wants to do it. I get 0.58. I'm just going out to 2 decimal places. I take the inverse sine of that and I get B is equal to 35.76. Okay, so now I know B is equal to 35.76. That's the angle in quadrant 1. But again, we have a matching angle in quadrant 2 where that is the reference angle. So I'm going to subtract that from 180 degrees and I'm going to get my other angle, right? Okay, so I have 180 minus 35.76 and I get 144.24. Okay, so now I have let's see what C is. So I have 40 plus 35.76 minus 180. So I have here 104.24. But notice when I add up 40 and 144, I get 180, over 184 degrees. So I know for sure that the biggest, that every triangle has 180. I can't make a negative angle. So this triangle only has one solution.
Okay.
Because there's no way, there's no C that will make that work. Okay, so we saw how the last one, we had two triangles, they both worked.
Mhm.
Here, I only get one triangle, and then I could just solve for A or for C using sine sine of A over A equals sine of C over C. And I already know what angle C is, so there it's not ambiguous anymore. I just plug in all those values and I'll find C. Okay, would you like me to do it, or do you feel comfortable?
No, I feel comfortable doing it. I have probably a silly question. I don't know.
Oh,
Uh,
of course, absolutely.
it might be entirely silly, but is it possible for this to not have a solution at all?
Yes, I'm gonna actually, I have one here.
Okay.
I do have one of each because sometimes you have no solution.
Okay.
Okay. So let's try this one. I don't actually know if this is the one or not, but there is one. Let's see. Actually, this is the one that has no solution. I'll do this one.
Okay.
Okay, so I start out with my triangle. And again, I put in my A, B, C, and A, B, C. And again, I only know, and you don't have to draw the triangles, honestly. I just like to, because I like to look at what it looks like.
Oh, I'm a visual person, so I'll have to draw.
Yeah, I'm very visual, so I always draw a triangle. And I guess it's really not necessary, but I always do. So again, I put in triangle one. And the reason I made this table, I actually taught for a really long time without that table. So that's why I now recommend it, because people would have their work all over the place, and what would happen without the table is they would use the wrong angle for the opposite angle. So
Right.
it, like, if you don't keep yourself very organized with this, you won't know what you're doing, honestly. So the table just helps. And then again, I only know this is 50 degrees, and I know this is 1 and this is 2. And that's again all I know, right? So I'm going to start with C, because I have both variables for C. So I have sine of C over C is going to equal, and I have one variable for A. So let's do the sine of A over A. So if I plug in my values, I get sine of 50 degrees over 1 is equal to the sine of A, which I do not know, over 2. And then I can say that the sine of A is equal to times the sine of 50 degrees. So A is going to equal the inverse sine of 2 times the sine of 50 degrees. So Tony, do you have a calculator there handy with you?
Not a scientific calculator, no.
Okay, because this is where it's really nice. Anybody who's watching this who wants to see what happens is what's going to happen. I can just tell you, because I don't need to do it. I know what's going to happen. I'm going to get an error.
I'll pull it up real quick. Let's see. Uh-oh. See if one of these online ones does it. Here. All right, so the inverse sine times 2 times the sine of 50. I don't think there's a degrees in here.
What kind of calculator is it?
It's just an online calculator.
Oh, there's a thing that says RAD or DEG. They all have to have it if it's scientific.
Oh, there we go. Okay, yeah, it says undefined.
Right, it says undefined. Sometimes it'll say error, depending on what calculator you use. So why would that happen? Well, if you just put in 2 sine of 50 degrees, what happens here is I get 150, I'm sorry, 1.53, 1.53. But really we're asking where does the sine of A equal 1.53? And what's the largest value that the sine can be?
1.
1. This is bigger than 1, which means it's impossible. So this is an impossible triangle. This will give you some error or undefined, whatever it gives you. It's because you cannot find the inverse sine of 1.53 because it's too big. So this one has 0 triangles. No triangles work.
Okay.
And what would really be happening here is the triangle would probably look something like C is 1, A is 2, this is 50 degrees. And they don't, like, it won't connect. Because it's just that the angle is too big for the sides that I have. Does that make sense?
Yes.
Okay, so that really is the basics. I showed you 0, 1, and 2. I have more examples if you think that it would be helpful to go through them. Notice these are ambiguous cases because I'm only given one angle. When I'm only given one angle, it's always the ambiguous case. And I always have to check to see if I have 0, 1, or 2 triangles. If I'm given, like where we began, notice I'm given 2 angles, which means I know all 3. So I mean, honestly, that's really it. I do have a word problem here we can do, or I have 2 more that I can do if you feel like that would be helpful. I'm happy to do them. Do you think me doing more would be more helpful?
Yeah, let's do
Okay. I have this one and I have that one. I'll do either one. It doesn't matter to me.
well, let's just do that one then.
Okay, so again, I always start with drawing it. I don't know if everybody has to do that. So I have A, B, C, and then I have A, B, C. I know this is 40 degrees. I know this is 3, and I know this is 2. So I honestly just start off with my table. So I have triangle 1, triangle 2, A, B, C. Can you hear that noise?
Yeah.
I'm really sorry. That's something to do with my computer doing weird things. So I apologize.
Okay.
So what am I being given? I'm being given that A equals 3, B equals 2, and A equals 40 degrees. And that's all I'm given. So I'm going to start off with, I'm given both things for A. So I have the sine of A over A is going to equal, and again, I'm given B, so I have to say the sine of B over B. And then I can solve this for the sine of B is equal to 2 times the sine of 40 degrees over 3. So I take the inverse of both sides, and I get whatever, I'll figure out what I get. So I get the inverse sine of the sine of 2 times the sine of 40 degrees over 3, which equals okay, so I get 25 point, I'll round it off to 0.4. So I know that one solution for B is 25.4, but notice that the original was not the inverse sine. So there's 2 possible values. Even though when I put it into my calculator, I only get 1, because remember, I've made it into a 1-to-1 function. So I'm actually only for sine between negative pi over 2, or I'm sorry, for this one, negative 90 to positive 90, right?
Mhm.
And this has to fall in between. But I have another side of that circle where the sine is equal to this positive value. So I just have to use this as my reference angle and subtract it from 180. So what is that? 154.6. I hope that's right. So now I know triangle. I know 2 angles for each of my triangles. So it's really easy to find the other angles. As a matter of fact, it's real easy here because this already adds up to 194.
Yes, that
Right.
will cancel out.
So this is not possible. So again, all I really have to do is solve one triangle here. So I have 40 plus 25.4, 80. So I get 114.6 degrees. And then now that I have all my angles, I mean, I could solve this all the way out. Let's see, I'll just do it over here. So I have the sine of 40 degrees, which is A, over 3, which is A, equals the sine of C, which I actually know now, right?
Mhm.
Divided by C. So C is going to equal 3 sine of 114.6 degrees divided by the sine of 40 degrees. And again, these will be calculator problems. You'll have a calculator. I do believe for these, you have to make sure you're in degrees and not radians. So be really careful. For a while, I know Alex just automatically changed it into the right thing, but at some point they stop and they want you to notice. So I think here you really do have to make sure it's in the right place. So here I get C is equal to 4.24. And let's see, does that make sense? Oh yeah, because C is obviously bigger than A and B, so it should be the biggest side, and it is. And that's it. And that's really the law of sines. It is really very straightforward. I mean, obviously the ambiguous case is the harder one, but you really do, what I find when I grade tests is that most people only try to find the one. And so they get it marked wrong. I give partial credit, but it's really important to notice that there are 2 possibilities and you should check for the other possibilities, or there's no possibilities. We've seen that as well.
Right.
So I think all I'll do is the same exact thing all over again. I think we feel pretty confident. I think what we should do now is do this word problem. I do believe there's actually a word problem in Alex that's similar. So to measure the height of a mountain, a surveyor takes 2 sightings at the peak of the peak at a distance of 900 meters apart. So he's taking, so between these two are 900 meters. So I know that side of the triangle. The first observation results in an angle of elevation of 47 degrees, which we can see is right here. And the second results in 35 degrees, which is right here. If the transit, so the transit, basically what that means is, if you notice, this is the bottom of the mountain, but it's going down. So they're saying that the transit is 2 meters high. So at the end, we just want to add these 2 meters in, because those aren't taken into consideration with the triangle that's shown. Do you see that?
Mhm.
Okay. And what is it I want to find? I want to find this height. Once I find that height, I add 2 and I have the answer to the height of the whole mountain. Now, yes, we can go along and just start solving everything, but I don't recommend just going at this like randomly, because what'll happen is you'll end up with way too much information. There's information you don't need to find. So you kind of want to think it out a little bit. All right. So I'm only given, the only real information I'm given is that side, and the degrees is 35 degrees of that angle, right?
Mhm.
So what do I want to do? I want to think it through, and I don't know the height, but I don't know really anything else. So let's just make a triangle, and I'm going to just use a triangle that looks like this, because I can't use the right triangle because I don't know this distance, so I can't use that. But I know this is 900, and I know this is 35 degrees. And I actually know what this angle is. Can you tell me what that angle is?
It would be 180 minus 47.
Exactly. So that this angle right here, if I know that a straight line is 180, I'm explaining to anybody else who's watching. So if I know that that's 180 degrees and I draw a line like this, and this is 47, then the other side has to be 133. Yeah, I think that's right. So I know now this angle is 133 degrees. And if I add those up, I have 168. So this up here is 12 degrees, right?
Mm-hmm.
Okay, great. So what do I want to find? I literally, if I find, here, let me use a highlighter. So if I find this side, and what else do I want to find? Actually, I don't even, let me say that again. I don't even actually need that side. What I really need is this side, because I know the number of degrees here, and I know that this is 90 degrees. So I already know what this is, right?
Mm-hmm.
So that's what 90 is 137. So this is 43 degrees. So if I find that line that I've highlighted, which is the same as this, I have really everything I need to find the height. Do you see that?
Yeah, yeah.
Okay, so what I'm trying to say is, first figure out what you need, because I originally said we needed the other side, and I have no use for that other side, honestly. So I could find it, but what would be the point? Okay, so let's name these. I'll call this ABC, and that means this is C, B, A. What I really want to find is A. And I know C. So I can use the sine of C over C is equal to the sine of A over A. And the sine of C is 12 degrees over 900 is equal to the sine of A, which is 35, over A, which is what I'm trying to find. So A here is going to equal 900 times the sine of 35 degrees divided by the sine of 12 degrees. And then we need our calculator. So sine of 35 times 900 divided by the sine of 12 equals, so A equals 2,482.8. Let's just say 283. I mean, for that, for the size of it, I think we can use to the nearest integer. And that would be 3. Okay, so now I know A is equal to 2483. And if I just pull that triangle out, I literally have a right triangle where this is 2483. This is 47 degrees. This is 43 degrees. And this is a right triangle. Now, do I need to use the law of sines again to find, because what am I trying to find? I'm trying to find H. So do I need to use the law of sines here?
I would say yes.
Okay, and I'm going to say no.
Okay.
And you could use the law of sines. I'm not saying you couldn't, but we already know everything we need to know about right triangles in a much simpler way, right? Because this is a right triangle here. So I know that the sine of 47 degrees is going to equal opposite over hypotenuse. And that's really what I know. I already know that from all the trig we've had before.
Gotcha.
And
Okay.
we actually don't need to ever use the law of sines for a right triangle.
Okay.
That's like, so the law of sines is really there for non-right triangles. Will it work with a right triangle? Of course it will, because here, if I use this as, say, C, what's the sine of 90 degrees?
That is 0.
1.
1. Sorry, 1. Yeah.
Right. So like, if I have sine of A over A equals, just for example, sine of B over B, I can also flip them, right?
Yeah.
That's the same as A over sine of A equals B over sine of B, right?
Right.
Well, if one of these is 90 degrees, it's just 1. So again, there's really no reason for me to use it. If I have everything else, which is what I really have, I don't need to do it. I can use my sine equals opposite over hypotenuse, my cosine equals adjacent, and so on and so on. Okay.
Yep.
So now this is pretty easy. I know that H is going to equal 2483 times the sine of 47 degrees. And again, that is just a calculator problem. So 47 degrees sine times 2483 equals, so I get the height is equal to 1,816 feet. But don't forget, we always have to add this 2. So it would be H equals 18 feet altogether. or the height of the mountain, not H, but I guess I should say the height of the mountain.
Mhm.
So H mountain, okay? And that's really all, that's pretty much everything. So when do you use the law of sines? When you don't have a right triangle. If you have a right triangle, it's just extra work to use the law of sines.
Right.
It will work, but it's more work than necessary. And that really concludes everything from the law of sines. I don't have really anything else to offer. I can answer any questions if anything didn't make sense. I have one more problem I can do if you want me to do it. Otherwise, we're kind of done.
I'm good. I don't have any questions. It was extremely straightforward. Probably
Yeah,
the easiest thing up until now.
yeah, this is really straightforward. The only thing that's not straightforward is making sure you check how many triangles. That's where I find people make the most mistakes, is that they just find one triangle and that's it. Because when you put these values into your calculator, because they're one-to-one functions, you're only going to get one answer back.
Right.
And then it's up to us to find out whether or not there is a second triangle. And there's a lot of rules. I mean, I was reading the book. I haven't read it for a little bit now, but I was reading the book, and it's something like, if this angle is bigger than this, or if this, it was a lot of rules you'd have to memorize. So I think it's a lot easier with the table, because I can easily see if I have a triangle that's over 180 degrees, it can't happen. And if I have a triangle like this one, where I get an error, again, that's no triangles. So I think it's easiest to just try to find the triangles, and if it doesn't work, it doesn't work.
Right.
And that honestly is the end of, that's my conclusion. You have no other questions. I'm going to turn off the recording.